Hello student, I hope you're doing well today. I wanted to talk about series circuit and just a matter of the technique I use whenever I'm building these circuits. This specifically relates to lab number 10, but this could apply to any series circuit. So I'm just using lab 10 for an example as far as the information we have here. So we're basically building this series circuit, as you can see in the schematic here. Yeah, and there's a picture of a proto board and one way you can do that, but usually what I do is I build a circuit in a straight line. To me it seems a lot easier and cleaner to do it that way. And in just a little bit, so there's my 4 resistors in series, and it's going to be these 4 resistors that I have I have a 150 ohm resistor here, I have a 330 ohm resistor here, I have a 1k ohm resistor here, and a 2.4k ohm resistor here. So what you would do is you'd go through and you'd measure these resistors individually and you record them in your data sheet. Now we're going to build this circuit, and we're going to build it in a straight line. So I'm using these big resistors just so you can see them easier. Usually in labs they're not quite as easy to use. And so I build my circuit here. All these resistors added up is close to 4,000 ohms. I think it's 3.88 k ohms. So I'm going to get my meter in here. We're going to set it to read resistance. So the first thing I do is measure individual resistors. Then I measure all the resistors together. I'm looking for 3.3 k ohm or 3.88 k ohm. I get a little bit higher than that. Looks like maybe an extra 100 ohms in there. And that's reasonable, that's respectable, we would do that. So there's my series circuit. For demonstration purposes, I will put my measurement with my meter over here to the right, and my power supply has been set for 17 volts. And I will apply my 17 volts here. There's the top one and the bottom one. As you can see with this circuit, as I have eliminated jumper wires using bus lines and stuff, I try to make it as easy and simple as possible, and that's just one of the things I do in order to eliminate any possible errors. Sometimes you can't eliminate that if you're building a complex circuit or dealing with some digital equipment and have multiple bus lines and multiple VCCs and multiple grounds. You'll have to use the bus lines, and you'll have many wires, and you'll just have to troubleshoot that. So now we're going to do voltage drops. So I'm going to put my meter up here. Let's see if we can put it right there, and I'll try to get a little bit wider shot here. There we go. Okay, so there we are, and so we're going to look at the voltage of R1. So I'm going to put this on voltage DC. So I'm measuring voltage on 1 by itself. Turn my power supply on. I'm not reading anything, so now it's time to troubleshoot. So move this out of the way. Make sure my leads are in the right spot. And it looks like I've got everything connected. Going to measure my voltage across the whole thing here. And I've got 17 volts there. So my applied voltage is good. I've got a connection somewhere. We'll just have to troubleshoot. Okay. All right, just a bad connection somewhere. So we're looking at something a little less than 1 volt there. We're going to move down to R2. And as you can see here, all I'm doing is I'm just moving my leads. This is my voltage leads. I'm measuring across my power supply there, and I'm reading about 1.54. We're going to move down to R3. So you see I'm connecting on these legs, but electrically that point from here to there is the same point, and this point from here to here is the same. So we're reading a voltage of 3, about 4.5 volts there. And let's take a look at this last one. And that's my voltage for the last one. That's the largest resistor, and that's the largest drop. So that's what we should expect. So we've taken opportunity to read individual resistors. We've read total resistance. I set up voltage, so I know what total voltage is good. And now we're going to measure current. So I've turned my power supply off. We're going to go to a wide shot here. And I'm taking my meter completely out. So the idea with a current meter is you're measuring the voltage through. So I'm going to disconnect my power supply, and I'm going to insert my meter like it was another resistor. So we're just going to put the meter in here. Now the one thing I have to do on most meters like this that are digital is I change this to read current, and I have to move this lead over to my current lead to read current here. And just a couple connections here, put that in there. And so I turn my power supply on. And that's my total current. I should expect about 4.38. I'm getting 4.2926, somewhere along in there. So that's what we should expect. So these are the techniques that I use whenever I'm measuring a series circuit. I measure the individual resistors for resistance. I build my circuit, measure total resistance. Then I measure individual voltage drops like we just did, and then I set up finally for total current. And that lets me go through the circuit. I can usually build a circuit and do all these measurements within about 5 minutes or so. I can do my analysis in another about 5-10 minutes to make sure my numbers are correct, and then we should be good to go. So I hope you find this helpful, and we'll see you in lab. Take care. Have a great day.